Hey everybody, and welcome back. This is the last lesson in our Module 1 folder for polynomials and cubic functions. So we're going to look today at pretty much factoring polynomials. So it's going to be looking at how do we factor them using greatest common factor, grouping, and then these special factoring patterns. And you'll see what I mean about that in a couple minutes. It's going to be probably a shorter lesson, but there's a lot of stuff in it. So please make sure you're taking very good notes, particularly for the special factoring patterns. I would recommend making some flashcards, some posters, something that's going to help you learn how to recognize those patterns. So there's very specific things you're going to be looking for, and you want to be able to find those. Essential questions for today: what does it mean for a polynomial to be irreducible? And how can I recognize the different factoring patterns? So in our last video, we looked at the degree of a polynomial. So we added, subtracted, multiplied polynomials, and then we figured out, okay, what was the degree? And that was based off the sum of the exponents on each term, and then the whole expression's degree was equal to the highest term degree. We wrote the equation of a polynomial based on the roots. So if I told you where a polynomial crossed the x-axis, you were going to be able to write for me an approximation of what that function might be, not knowing necessarily the a value though. And then recognize the multiplicity of factors. So if a factor is repeated, how many times is it repeated? And you can tell that from looking at the graph of the function. Factoring polynomials using greatest common factor. Now you guys, you know what greatest common factor is. It is pulling out anything that is a common factor to all of the terms in an expression. So if we have these two examples here, looking at the first one, we would say, all right, what is common to all three terms? Well, they all have x's. The highest degree of x that's common to all of them is 1. So like this one has x times x. The first one is x times x times x. 2x is 1x. So there's 1x common to all of them. And then 6, 15, and 6, they all have common factors of 3. So the last one would be 2 times 3, 5 times 3, and 2 times 3. So we can pull 3 out from all of them as well. So we would say this is 3x. There's your greatest common factor. Parenthesis, what's left? So we've got 2x squared plus 5x plus 2. That makes sense so far? And then you would say, okay, so 3x must be a factor. Now you also would say, I'm down to a quadratic, go back to normal factoring ideas for quadratics. So 2x squared plus 5x plus 2, well, the a value is bigger than 1, so we'd multiply a and c, so we get 4. Factors of 4 that add up to 5. We've got 1 and 4. So we go to our window pane method. We got 6x cubed, or sorry, not 6x cubed. We're going down to our quadratic part. So it come down here. So the 2x squared and 2 going down in the bottom right. And we've got 4x and 1x. So factors of 2x squared, we've got 2x and 1x. 1x times what is 1x? It's 1. 2x times what is 4x? It is 2. So that means my factors are 2x plus 1 and 1x plus 2. And then that third factor is 3x, so taking it from above. So this would be the polynomial in factored form. So you're writing it down into its factors, and if you want to solve for the zeros, you could do. So that would be x equals negative a half, x equals negative 2, and x equals 0. So those would be my 3 zeros if I were to find the zero. So we got factored form and then solved. Going over to the other one, 2x cubed minus 20x. We've got 2 as a common factor of both, and 1, so x to the power of 1 as well. So we would pull out the 2x, and that leaves me with x squared minus 10. Now x squared minus 10, even though it's an x squared, there's no other way to factor this down into anything smaller. So we would say that x squared minus 10 is irreducible. It's as factored as far as it possibly can be. So that's what that word, it's in our essential question, what irreducible, or irreducible is another way that I sometimes have seen it pronounced, but irreducible is how I would say it. It cannot be reduced any further. So then you would end up saying, all right, well, that means that x is equal to 0, or x is equal to plus or minus the square root of 10. And those would be your zeros. So you'd have 1, 0, minus negative 10, and positive negative 10, root 10, sorry, will be your zeros. So the factored form, solution. So your turn. Greatest common factor, pull it out, and then finish factoring the polynomial. Take a break, come back when you are ready to see the answer. All right, welcome back. So we've got 3x cubed plus 7x squared plus 4x. 3, 7, and 4, no common factors, and it looks like just x to the power of 1 is a common factor. So we've got 3x squared plus 7x plus 4. So then, quick look at 3x squared. So 3 times 4 is 12. So yeah, we will be able to do this. All right, so x is going to be one factor. We're going to have to factor the quadratic. So 3 times 4 is 12. And we need factors of 12 that add to be 7. That's 4 and 3. So I need my window pane. I've got 3x squared, 4, 4x, and 3x. I know that top left is a little messy, so I'm going to redo that. So we've got 3x squared. So factors of 3x squared are 3x and x. So 3x times what is 3x? It's 1. X times what is 4x? It is 4. So we've got our factors are the x from above, so x, 3x plus 4, and x plus 1. So that would be my factored form of the polynomial. And if you distribute it, you will get back your original polynomial again. If we were asked to solve it or find the zeros, we would say x is equal to 0, x is equal to minus 4 over 3, or x is equal to negative 1. And that's it. Factoring by grouping. This is more of a recap of Algebra 1 because it's pretty much the exact same method as what you did in Algebra 1, just maybe that some of your groupings you can factor down even further. So just kind of keeping an eye out for that. So when you factor by grouping, you are looking for pairings in the terms that share common factors. So in the first one here, x cubed minus x squared, they share a common factor of x squared. So you would pull out the x squared, and then what's left over will be an x minus 1. For the second one, x minus 1, there's no common factor except for the number 1. So you pull that common factor out. So you do have to find a common factor. If there's nothing else, you just pull out a 1. And then what you notice is that they both have a factor of x minus 1. So you'd say, okay, if I take the greatest common factor out of that, it would be x minus 1, and then we'd be left with x squared plus 1. Seem all right? Yeah, there's nothing else I want to do with this right now. When we see this later, we'll look at this x squared plus 1 and be like, oh, we can do a little bit more with that maybe. But for now, I'm pretty happy with just leaving it as x minus 1 times x squared plus 1. So that'll be our factored form. So factor the following polynomial and try and do it by grouping. So pause the video, come back, and see what the answer is. All right. So a couple ways you could approach this. You could do like the first term, the third term, and the second and the last one. Usually the first and the second works just fine, and same with the last one and the fourth one. So greatest common factor of the first two is just x squared, and you get left with an x plus 3. And then the second one, 3 is the greatest common factor, and you get left with an x plus 3. So then x plus 3 is your greatest common factor, and the other one is x squared plus 3. And x squared plus 3 is irreducible, so we are done. All right, this is the special factoring patterns. And the reason why this is in a table like this is that you're going to need to be able to recognize these scenarios. And there's no real like quick solution to this other than you need to actually go and learn these. So memorization, flashcards, posters, it's what's going to make life easier for you. So difference of two squares, we should know this one already. So if you have a number squared minus another number squared, or you can rewrite it in this format, then its factors are the two of them added and the two of them subtracted. So difference of two squares, we should be pretty familiar with this one already. A perfect square trinomial, we should know this, like we've done it before, like we've done a lot of distributing of binomials like this. But if you have a squared and a b squared, so two numbers in there that are both square numbers, that should be kind of your hint. And then you look at the middle term and see, is it 2 times the a and the b value multiplied together? If that's the case, you can rewrite it in factored form as a plus b to be squared, which, remember, that would be a plus b times a plus b. So that would be a factored form version of it. Same thing, but if the center term is negative, then it could be a minus b squared. So you would check and see, okay, does it fit this pattern? Do you have an a squared value? Do you have a b squared value? And then is the center one -2 times the a and the b multiplied? Sum of two cubes. This is something that's a little bit new to us. So if you have two numbers that can be written as something cubed and they're added together, the factored form, so you can break it into factors, you would have a plus b, and then you'd have a squared minus ab plus b squared. So notice it's not the exact same as perfect square trinomial. It's minus ab instead of minus 2ab. So you can't simplify that further. That's irreducible at that point. When we're factoring something, we're trying to break it down into two or more terms that can be multiplied where the degree on those terms is less than the original function. So that's what we're kind of trying to do. So the fact that a and b are both cubed here, even though it looks like this doesn't, like the bit on the right isn't simpler, all of the a's and b's are a lower degree than what they were in the beginning. So it is technically a factored version of it. And then that's the sum of two cubes. So two cubes add together. Difference of two cubes, almost the exact same factor form, except the signs change in two key spots. So instead of it being a plus b, it's now a minus b for the first factor, and then it's a squared plus ab as opposed to a squared minus ab. So that's one where you're just going to have to, guys, get a lot of practice in and maybe have posters, flashcards, something to help you remember what the factored form of those things is going to look like. Because it's not one of those ones that you can really pull out, like you can't really work through it as easily. So you have to do a lot of guess and check pretty much to do that. So learning your patterns is going to be a very important thing. All right, so let's factor the following polynomials. So we'll start with some of the more familiar stuff. 16x to the power of 4 minus 25y squared. So the key here is that you need to recognize that this is actually a difference of two squares scenario. So you've got two terms. They have even exponents. That's a hint number one. And then the numbers, the numerical parts, are both square numbers. So 16x to the 4, I can rewrite that as 4x squared all to be squared. So that means 4x squared is my a value, minus 25y squared. So if I subtract 5y to be squared, that makes 5y my b value. So you have to be able to rewrite your terms as something to be squared. And the whole thing has to be to be squared. So then my factored form would be 4x squared plus 5y, 4x squared minus 5y. So yeah, see the difference there. So it's 16x to the 4. Yeah, x to the 4 we can't really do much with, but it can be written as x squared times x squared. 16 can be 4 times 4, so 4x squared to be squared makes sense. It works. Same thing with the 25y squared. That's 5y all to be squared. So it's one of those things, guys, that if you're just kind of paying attention to this for the first time, like in Algebra 1, you didn't really devote much time to difference of two squares, because you could kind of get away with it. You're going to have to spend some time on it now, and there's no shortcut to this. You just have to practice. So if you need extra help with this, I would look up difference of two squares on Khan Academy, on YouTube, on Google, and find as many practice problems as you can to help you just kind of get used to recognizing square numbers and then rewriting them in factored form. All right, the second one. This one, again, on first glance, seems a little odd, but we've got an a squared and a c squared, and 9 and 16 both square numbers. That to me is setting off alarm bells that, okay, I might have a perfect square trinomial on my hands. So quick check of that would be, all right, 16a squared, that's 4a all to be squared. And then 9c squared is 3c all to be squared. And then you've got a plus 24ac. So the one I'm looking for here is the a plus b all to be squared. And that ends up being a squared plus 2ab plus b squared. So I'm trying to figure out, is this actually a perfect square trinomial? So my a value is 4a, my b value is 3c. If I multiply those, so ab, that would be 12ac, and then times 2 is 24. So yes, this is a perfect square trinomial. So that means I can rewrite it in the form a plus b to be squared. This is the factored form, or if you really want to write it out, so it's 4a plus 3c twice. Now that one, again, harder to recognize. You're looking at that first term and the last term, spotting that they're potentially like square numbers, so you can rewrite it as something, I know there's a's in here as well, but something to be squared and something to be squared, and then you're checking that middle term to see, okay, is it 2 times a times b? And if it is, all right, great, I can dump this down into its factored format. So once again, it takes practice to spot these things. All right, this one here, 27x cubed plus 64. Now, your cube numbers, if you're not very familiar with cubed numbers, then you probably need to make a list of those, get that displayed in your room somewhere, because that's really where you're going to save yourself some time. Like, did you know that 64 is a cubed number? Did you know that 125 is a cubed number? So if you think of it, we've got, so if this is our original number up here and x cubed, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and then 10 cubed is 1,000. So even if it's just the first 10 numbers, I would make a list of those, a poster or something like that, and start looking to recognize your cubic numbers. We did the same thing with square numbers, don't forget, for simplifying radicals. We just needed to know what were our square numbers, because that made life a lot easier when it came to trying to factor it and figure out, okay, how do I break it down? So do you know your cubed numbers? That would be a great question. So 27 is a cubed number, 64 is a cubed number, x cubed is a cubed number. So we can rewrite this as 3x all to be cubed plus 4 to be cubed. So this is in the format of a plus b, where both of them are cubed. So in factored form, you've got a plus b times a squared minus ab plus b squared. So what we can do then is say, all right, that means 3x is my a value, 4 is my b value. So factored form would be 3x plus 4 times a squared, so 3x to be squared would be 9x squared minus 4 times 3x, so that's 12x. And then we've got plus b squared, which is 16. So yeah, that's my factored form. And then I would look at the quadratic and see, like, can that be factored down any further? At the moment, I'm cool with us saying no. So if it's pretty much shown up here that this is not irreducible, you can't factor that down any further. So we don't need to check any further. But 3x plus 4 and then 9x squared minus 12x plus 16, that is the factored form of 27x cubed plus 64. So yeah, this whole lesson's a little bit more challenging, some new stuff in here. You're going to have to spend some time practicing it to get confident at it. And then the other one, 8x cubed minus 125. 8 is a cube number, 125 is a cube number, x cubed is a cube number. So we would rewrite this as 2x cubed minus 5 cubed. So this one is in the form of a cubed minus b cubed, so a difference of 2 cubes. Same as the last one, except the signs change. So a squared plus ab plus b squared. So that would be 2x minus 5 times 4x squared plus 10x plus 25. And that's our factored form. That's it. Done. Typically what happens here, if this is irreducible, it means that you've got imaginary solutions or very complex solutions. So like if we were to say, okay, I want you to solve this, so put it equal to 0 and solve it, you'd have your 2x minus 5, so x is equal to 5 over 2. But then you'd have to actually go solve the other one. You might get complex, you might get imaginary solutions, which is, of course, possible. All right, your turn. 4 questions here. We do need the practice. I gave you a lot of different scenarios, so definitely take your time and come back and see how you did. All right, the 8x cubed plus 125. We saw something very similar in our example. So this would be 2x all to be cubed plus 5 all to be cubed. So it's a cubed plus b cubed. So that means that we've got 2x plus 5 and then a squared minus ab. So 2x times 5 is 10x plus b squared, 25. Second one, we've got 36x squared minus 60x plus 25. So it's 3 terms. 36 is a square number, 25 is a square number. So I'd be looking at that and thinking, all right, so it could be a perfect square trinomial. Let's take a look. So 36 would be 6x all to be squared. 25 is 5 squared. All right, so 6x times 5 is 30x times 2 is 60. So I'm like, okay, I've got that perfect square trinomial going on here. So that would be a squared plus, or sorry, not a squared, a, where's my pen? A plus, sorry, minus b all to be squared. So that would be 6x minus 5 all to be squared. So if you distribute that, 6x times 6x, 36x squared, negative 5 times negative 5 is positive 25, and then 6x times negative 5 is negative 30, and you would do that twice, you get the minus 60. Done. So this is your factored form. X cubed minus 64, y cubed. Both cubic numbers, remember 64 is a cubic number. So we've got x to be cubed minus 4y to be cubed. So it's the difference of 2 cubes. So that's a minus b, so x minus 4y times x squared plus ab, so 4xy plus y squared. So 4y to be squared would be 16y squared. There's our factored form. All right, last one. 40 is not a square number. So that's interesting. But they have a common factor. So let's pull that one out first and see what's left. So 40 and 5, common factor would be 5. X to the power 4 and x, common factor is x. So 5x is a factor. That leaves me with 8x cubed plus 1. Now we're talking because 8 and x are both being cubed, so they're both cubic numbers, and then 1 is also a cubic number. So this can be rewritten as 5x times 2x to be cubed plus 1 cubed. So we've got two cubic numbers, the a cubed plus b cubed. So in factored form, the 5x is still there. We've got the a plus b, so 2x plus 1. And then we've got a squared, so 4x squared minus ab, so that's minus 2x plus b squared. There's our factored form. So 5x, 2x plus 1, 4x squared minus 2x plus 1. So how did you do there? That's one where you could even go back, start the slide again, and see, can you write it out in factored form? So like rewind so you don't see the answers and try it again. If you want to practice this even more, search things like factoring polynomials. You're going to have a lot of Khan Academy practice on this too, so you'll be able to kind of do those over and over again to get lots of extra questions as well. So our essential questions for today: what does it mean if a polynomial is irreducible? So usually it's part of the polynomial, and it just means that it cannot be factored any further, so it cannot be reduced any further into simpler terms. Sometimes because it's going to have complex solutions, sometimes because it's going to have imaginary solutions. How can I recognize different factoring patterns? That's the hard question, isn't it? How do you recognize when you have a plus b to be cubed, or the difference 2 cubes, sum of 2 cubes? So you have to look at that chart where you have the 4 different things shown, and you have to study that. So make sure that you know it, you can reproduce it. If you are doing open note tests, that is available to you somewhere. So you've got the opportunity for note cards here. Make sure you're practicing using it. So have it laminated, nicely colored, easy to recognize, and use it along the way. All right, so you have finished Unit 3, Module 1 at this point. You have the math task to complete, and you also have checkpoint 1 to do. So Unit 3, checkpoint 1. So this is our first quiz of Unit 3. Make sure that you are very comfortable on the factoring of polynomials before you take that checkpoint. All due by Friday, and you also have one lesson from the next module. So make sure you include that in your plan for getting everything done this week.